This is the last video for section 6.2 in AP Stats, and we're going to use the rules that we already know on how to combine random variables. So far, we've only talked about discrete random variables, which have a countable number of outcomes, but the same rules also apply to normal random variables, where it can kind of be anything, a continuous, anything in a range of values. And normal random variables are very, very common, so it's certainly worth looking at. Just have a couple examples of adding and subtracting two normal random variables. All right, here you go. First one says Scott's bowling scores are normally distributed with a mean of 176 and a standard deviation of 19. And Will's bowling scores are normally distributed with a mean of 157 and standard deviation of 13. And the information that I wrote there in red and blue is just that information summarized. If Scott and Will each bowl one game, what is the probability that their total will be 345 or higher? So we actually want, I didn't write this down, but maybe we should have, we want to find the probability that S plus W is greater than or equal to 345. That's what we're looking for. And actually, I probably wrote that down here somewhere. There it is. So since both S and W, Scott's and Will's bowling scores, have normal distributions, so does the sum of those two. So we have to use these formulas that we've been talking about to find the mean of S plus W and the standard deviation of S plus W. And I'll remind you, as I've said many times, finding the mean is always easier because it's always intuitive. I think it's pretty clear that the mean of the sum, if they both bowl one game, and I want to know what the average is of their sum, it is in fact, the mean of S plus W is in fact the mean of S plus the mean of W, which in this case is what's 176 plus 157, which is, I don't know, 333. So it makes perfect sense that the average of their sum would be the sum of their averages. Okay, and that nothing difficult about that. But the standard deviation is where it's tempting to do the wrong thing. I'll remind you what you cannot do to find the standard deviation of S plus W is just add the two standard deviations. Because what we learned last week or earlier this week, whenever it was, about random variables is that the standard deviations don't add, the variances add. That's still really the important conclusion from this. So we know that the standard deviation is the square root of the variance. That's true for any random variable. So I don't have to first find the variance, which is sigma squared S plus sigma squared W, and I need to square root that. So it's remembering that the variance is add, not the standard deviations. The problem's not going to give you the variance, although it's just the standard deviation squared. So now we need to figure out, so this is the square root of 19 squared plus 13 squared. And I've got my calculator right here. I'll just do that. If I do 19 squared plus 13 squared, I get 530. Let me move this down a little bit here. Oh, no, like that. Like that. There we go. So we're still finding the standard deviation of this S plus W. So this is the square root, turned out to be the square root of 530, which is whatever that is. I'll figure that out here. It's the square root of 530, 23.02. So now I have this random variable. It is S plus W. Excuse me. It is S plus W, and the mean of S plus W is 333, and the standard deviation is 23.02. So we just found the mean and standard deviation of this random variable S plus W. So now if I want to find the probability that that random variable is greater than or equal to 345, now that is just a normal CDF calculation. So I'm going to need to see the other numbers here. So that's just normal CDF. What was it, 333? So my lower bound, my upper bound, so 333, 9999. Oh, not 333. That would be a typo, right? I want to probably that was greater than 345, comma 9999, comma 333, comma 23.02. Remember normal distribution, normal CDF, lower bound, upper bound, mean standard deviation. And let me draw this here before I calculate it. Remember, this is now, didn't mean to use a highlighter. This is a normal distribution, the mean of which is 333. And I want to know the probability that it is 345 or higher. So I'm looking for this shaded region, just a normal CDF calculation. That's now if I actually go back and do the calculation. Let's see, second distribution, normal CDF, lower bound 345, upper bound 9999. The mean, so comma, the mean was 333. Standard deviation is 23.02. Oh, no typo, 23.02. And I get 0.301. So it turns out they have a 30% chance of getting a total score, the sum, 345 or higher. So there's an example of how we need to remember that the variance is add for random variables. Next example is, okay, now let's talk about differences. And this is just remembering what's up with differences. Now we're talking about Mr. Wagner and me golfing. Mr. Wagner's golf scores are normally distributed with a mean of 82 and a standard deviation of 3. That's the information right there, mean and standard deviation for Wagner. And Mr. Knoll's golf scores are normally distributed with a mean of 81 and a standard deviation of 4. That's in blue. Here's my data. If they play golf, what is the probability that Mr. Wagner wins? Now, of course, you need to know that in golf, winning means a lower score. So we're trying to find the probability that W is less than K. And I don't know how to do that, but by being a little sneaky, if I subtract K from there and I subtract K from there, from both sides of inequality, I get the probability that W minus K is less than 0. And that I can figure out because we now have this new random variable, W minus K. So let's find the mean of it. Let's find the standard deviation of it, and then we'll just do a normal CDF calculation. So the mean is just like you'd expect. On this next, we're going to have the mean of W minus K is, in fact, the mean of W minus the mean of K. So that was the mean of, let's see, what was that? It was Wagner was 82 and Knoll was 81. Yes. So this is 82 minus 81 is 1. So the expected difference, Wagner's score minus my score is 1. That's the mean. And then again, now I need the standard deviation of W minus K. And I certainly just can't take standard deviation minus standard deviation. But then remember the conclusion that we said is even when you're finding the standard deviation of a difference, the variances of difference still add. Not intuitive, but true. So we still have to take the variance of Wagner, and we have to add the variance of Knoll, and then we have to square root. That's the same formula that we used in the last example with the sum. That formula is the same whether it's sum or differences. So this is the square root of, let's see, that was 4 squared or 3 squared and 4 squared. The math here is very convenient. That's the square root of 25, which turns out to be 5. So it turns out that this random variable, W was Wagner minus Knoll, W minus K, is normal with a mean of, 1, and the standard deviation is 5. And now to find the probability that W minus K is less than 0, well, I have a normal distribution. My mean is now 1. Here is 0. I'm looking for that probability. Hopefully you see that as a normal CDF, which I will type in small here so it fits. I'll put it right here. So this is a normal CDF. And let's see, my lower bound is negative 9999. My upper bound is 0. My mean is 1. And my standard deviation is 5. And again, I'll get out my calculator. Second distribution, normal CDF, negative 9999, comma 0, comma 1, comma 5. Turns out to be 0.42. I almost got out my pen. 0.42. So apparently there's a 42% chance that Mr. Wagner will beat me when we play golf. So there's your explanation of how we can use the rules we learned with continuous normal random variables. And your assignment only has maybe 7 or 8 problems. It is only 6 problems, 59 to 62 and 65 and 66. And this is the end of section 6.2. So early next week, we will start section 6.3. So enjoy the rest of your weekend, or enjoy your Monday if you're watching this on Monday. Have a great day.